in this problem, we have been asked to find what is the new place of the origin, or in other words, where we have to shift the origin, so that the locus which is represented by this equation, so it's an equation, it's a second order equation with first order terms. The first order terms need to be eliminated. So, in order to do that, we need to find the new place of the origin. So, let us try and write this equation as the sum of squares, so that we can actually see how we can eliminate the first order terms. So, if you just do a little bit of work, you can write it as twice x minus 1 the whole square minus twice y. So, here this is equal to 8. So, if you take the 2 out, so it becomes, so twice y minus 2 the whole square, and finally plus z plus 1 the whole square. So, by writing it like this, we have actually taken care of all the second order and the first order terms given in this equation. The only thing is we have to match for the constant term. So, here if you look at it, the constant term is equal to plus 2, and here again it is equal to plus 2. So, we have plus 4, or here we have plus 1 actually. So, we have plus 3, and here we have minus twice of 4, which is minus 8, plus 3, so minus 5. So, therefore, we have actually matched the constant term also. So, what we have seen is we have basically broken down this equation into a sum of squares. So, once we have this, the answer to our problem actually follows immediately, because if you make the substitution that if I take x equals this x minus 1 and capital Y equals y minus 2 and capital Z equals z minus of minus 1, which is z plus 1, then if I make these substitutions, then this equation actually becomes 2x square minus 2y square plus z square equals 0, which is exactly the form which we wanted. That is, it's a form in which there are no first order terms. Now, what is this algebraic substitution? What does it mean geometrically? It actually geometrically means that we have shifted the origin to 1, 2 and minus 1. Because of, if you go back and look at how the equation varies when we shift the origin, then this is the relation between the old coordinates and the new coordinates. So, what one can say immediately is that the origin needs to be shifted to the point 1, 2 and minus 1. So, this is a standard problem wherein in order to eliminate the first order terms, you write it as a sum of squares and then find out the new origin.